Good morning to one and all gathered here. I am Dr. J. Philomena Carlin from Department of Mathematics, SRM, Madurai College for Engineering and Technology at Sivagangai. I have finished MSc B.Ed MPhil PhD in Mathematics. I have 7 years experience in teaching and 11 years experience in research works. I have published 6 papers. Among these 6 papers, 3 papers are published in Springer and 3 papers are published in an international journals. I have presented some papers in Malaysia, Uttar Pradesh, Kochi, Chennai, Periyakkulam and Dindigul. Now I am going to give some ideas on how to reduce the quadratic form to canonical form. In this section, we are going to discussing about introduction, matrix of the quadratic form of the matrix, reduce the quadratic form to canonical form, and conclusion. First one is matrix of the quadratic form. Let a11 x1 squared plus a22 x2 squared plus a33 x3 squared plus 2a12 x1 x2 plus 2a23 x2 x3 plus 2a13 x2 x3 be the given quadratic form. Then the matrix of the quadratic form is Q equal to coefficient of x squared half into coefficient of xy half into coefficient of xz half into coefficient of yx coefficient of y squared half into coefficient of yz half into coefficient of zx half into coefficient of zy and coefficient of z squared. Using this formula, we are going to write the matrix of the given quadratic form. That is 2x1 squared minus 2x2 squared plus 4x3 squared plus 2x1 x2 minus 6x1 x3 plus 6x2 x3 be the given quadratic form. Now we are going to use the above mentioned formula. Then finally we can get the 3 cross 3 matrix such as 2 1 minus 3 1 minus 2 3 minus 3 3 and 4. Next one is quadratic form of the matrix. Let Q be the given symmetric matrix form. Then the quadratic form of the given matrix is a11 x1 squared plus a22 x2 squared plus a33 x3 squared plus 2a12 x1 x2 plus 2a23 x2 x3 plus 2a13 x2 x3. Using this formula, we are going to write the quadratic form for the given symmetric matrix, that is 2 0 minus 2 0 2 1 minus 2 1 minus 2. From this we can get the values a11 equal to 2, a22 equal to 2, a33 equal to minus 2, a12 equal to a12 and a21 is equal to 0, a23 and a32 is equal to 1, a31 and a13 is equal to minus 2. So applying these values in the above mentioned formula, we can get the quadratic form as nothing but 2x1 squared plus 2x2 squared minus 2x3 squared plus 2x2 x3 minus 4x1 x3. Now we pass on to the important section of this video is nothing but how to reduce the quadratic form to canonical form. The given quadratic form is nothing but 8x1 squared plus 7x2 squared plus 3x3 squared minus 12x1 x2 minus 8x2 x3 plus 4x3 x1. Now we are going to apply the formula for the matrix of the given quadratic form. Then we can get the 3 cross 3 matrix such as 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Now we are going to find the characteristic equation of the matrix. The formula for the characteristic equation of the matrix is nothing but lambda cube minus s1 lambda squared plus s2 lambda minus s3 equal to 0. Where S1 is the sum of the main diagonal elements. Here the sum of the main diagonal elements of the given matrix is nothing but 8, 7, 3. So S1 is equal to 18. S3 is the sum of the minor of the main diagonal elements. The minor of the main diagonal elements is nothing but 7 minus 4 minus 4, 3. The second one is 8, 2, 2, 3. Third one is 8 minus 6 minus 6, 7. Adding and solving these equations, we can get S2 equal to 45. Next, S3 is equal to determinant A, and solving this matrix of determinant, and we can get S3 is equal to 0. Applying this S1, S2, S3 in the given characteristic equation of the general form as, and we can get the values lambda cube minus 18 lambda squared plus 45 lambda equal to 0. Next, we are going to find the eigenvalues. So now we can take the lambda outside from the given above equation, and we can get lambda into lambda squared minus 18 lambda plus 45 equal to 0. Now we can factorize this equation lambda square minus 18 lambda plus 45. Then we can get the factors lambda minus 15 and lambda minus 3. Finally, and also we have lambda is equal to 0. Solving these equations, we can get the 3 eigenvalues, lambda equal to 0, 3 and 15. Now we are going to find the eigenvectors. So for that, we have to find a minus lambda into x equal to 0. So we can formalize this equation as it is given in the slide. So in this situation, we can solve this eigenvectors as 3 cases. In case 1, we have to substitute the lambda values, that is lambda equal to 0 in equation 1. We can get 3 linear equations, and solving these linear equations, finally we can get the eigenvectors x1 is equal to 1, 2, 2. In second case, we have to substitute the eigenvalues lambda equal to 3 in equation 1, and we can get the 3 linear equations. Solving these equations, we can get the second eigenvector x2 is equal to 2, 1, minus 2. In third case, we have to substitute the eigenvalues lambda equal to 15 in 1. We can get the 3 linear equations. Finally, we can get the third eigenvector x3 is equal to 2, minus 2, 1. Now we are going to find the normalized matrix. The formula for the normalized matrix is nothing but if x is equal to x1, x2, x3, then the normalized vector of x is x1 divided by L, x2 divided by L, x3 divided by L, where L is equal to root of x1 square plus x2 square plus x3 square. Applying this formula, then we can calculate the normalized matrix n equal to 1 by 3, 1, 2, 2, 2, 1, minus 2, 2, minus 2, 1. Now we are going to find out the diagonalized matrix. The formula for the diagonalized matrix is D equal to n transpose an, where n is the normalized matrix. So here n transpose is nothing but 1 by 3 into 1, 2, 2, 2, 1, minus 2, 2, minus 2, 1. And next we are going to find the an, and substituting these values in D, we can get the diagonalized matrix is nothing but 0, 0, 0, 0, 3, 0, 0, 0, 15. So now we are going to found the canonical form as y dash dy, where y dash is nothing but y1, y2, y3. It is a 1 cross 3 matrix. Where y is nothing but y1, y2, y3. It is a 3 cross 1 matrix. Applying these matrices and solving these multiplications, we can get the canonical form 3y2 squared plus 15y3 squared. So in this session, how to reduce the quadratic form to canonical form by using orthogonal transformation. So particularly, we have find out characteristic equation, eigenvalues and eigenvectors, normalized matrix and diagonal matrix, and canonical form. Thank you.